Chapter 10, Lesson 6, the angle bisector theorem. We get another theorem, and this one, fortunately for us, has a name. So when you're doing a proof, you can just put in there angle bisector theorem. This is a fun theorem. It says an angle bisector divides the opposite side into segments that have the same ratio as the other two sides. So in English, here we go, English, this is what it's saying. If you have a triangle ABC, if BD bisects angle ABC, which means it divides it into two equal angles, then the sides are going to form this proportion. We're going to have AD over DC, so that's the side that's, it's not bisected, but it's cut in two. AD over DC equals AB over BC. So it's the bottom two parts proportion to the side two parts. Now the AD part goes with the part that it's closest to. So AD goes across from AB, DC goes across from BC. These are easy and fun, but we do, as you can see, have a proof coming up down there. So hold on one second, let me get some changed back to white. That purple's a little annoying, or pink, or whatever it is. Okay, here we go. So this is what a problem's going to look like. They're giving you a triangle, and they show by these equal marks that these two angles are equal. That means that this segment bisects this bigger angle. So we know that the ratio is going to be equal. So here we go. We set up ourselves up a proportion. So we're going to have, now look, it's the bottom segment over the other bottom segment. So our one bottom segment right here is x. The other bottom segment would be right here, it would be 6 minus x. Because if this is x and this is 6, this has to be 6 minus x. So it's x over 6 minus x. The side that goes with the x would be the 7, and the side that goes with the 6 minus x would be the 3. So you just set that up, you cross multiply, 3x equals 42 minus 7x, and you get 10x equals 42, and x equals 4.2. So there's a little bit more algebra in this chapter and in the rest of the book than what we've had before, so hopefully that comes back to you. So that's the answer to that one. I had to cram everything all in this one whiteboard because I got some new software with my new computer and I haven't found a good one to do lessons yet. Anyway, let's go down here to example 2. Same thing. So you just set up your proportion. So it's going to be 4 over 6, like that, equals, the 4 goes with this one, so it'd be x plus 1 over x plus 5. Cross multiply. Let's see, how am I going to squeeze this in here? So we get 4 times x plus 5 equals 6 times x plus 1. And if we do all that solving, we get 26 equals 2x, x equals 13. Hopefully you guys can solve those equations. Okay, example 3. This is number 6 from your book. So we have, they're just telling you which one, they're just asking you what would go in this box right here. So we have BE, these are so easy, BE, EL. Well, BE would go with BW, so EL goes with WL. And that's it. I know, it's a little ridiculous. And let's just try one more. LW over WB, oh, they're mixing it up for us, this is tricky. So we know that LW is going to go with the one closest to it, so it's going to be EL. And this one would be BE. Super simple. All right, we're going to try a proof. I even like the proofs in this section. Now I have to fit it all in this spot. That's the only hard part. Okay, so you're given angle 1 is equal to angle 2, EA. This one is equal to AR. And we have to prove that EN is equal to NR. So we have our given down. We can say because angle 1 is equal to angle 2, we can say that AN, segment AN, bisects angle ENR. And that's a segment bisects an angle if it divides it into two equal angles. So a segment bisects an angle if it divides it into two equal angles. All right, kind of long there. All right, so because it bisects, we can go up and use our angle bisector theorem. It says an angle bisector divides the opposite side into segments that have the same ratio as the other two sides. So now we can set up a ratio. Because it bisects it, we can say that EA, down here, EA over AR, remember this, EA, AR, equals EN over NR. And that is your angle bisector theorem. Now we can cross multiply, go this way and go that way, and so we're going to get EA times NR equals AR times EN. And that's just multiplication. Whoa. And that's that. Now look what we're trying to get. We're trying to get, our proof is that EN equals NR. EN equals NR. So we want these two to be equal. But if you look up here in your given, we know that EN equals NR. So I can substitute in and say that EA times EN, because EN equals NR, we can substitute, equals AR times EN. And that is just substitution. We're almost done. And then finally, we can divide both sides by EN like this, and we'd say EA equals ANR. Whoops, how do I have an AR there? I think I copied something down wrong here. EA times EN. Whoops. I think I put these on the wrong parts here. I should have EA over AR equals EN over NR. That's fine. AR times, oh okay, I'm fine. I just substituted wrong at the top. Hold on, let's go back up here. I just substituted differently than I did initially. So we're going to get EN EA times NR. Yeah, NR. That was right. I'm going to substitute in NR equals AR EN. So I'm going to say AR, and then instead of this EN, I'm going to say NR. There we go. Okay, sorry about that. That's substitution. Sorry, it looks awful. Now our NRs cross out, and we get, oh, what happened there? Oops, the EA should have crossed out. Okay, here's the problem. I'm not going to redo this. I wrote the wrong thing here. I'm not going to redo this whole video because of this. I copied the wrong thing down. EA equals AR. So this would have been, I'm just scribbling this out. I'm not even going to have room to finish this. So finally, we have we need to replace EA by AR. AR times NR equals AR times NR. And that's our substitution. And then finally, these NRs will cancel out and we'll get what we're trying to prove, and that will be division. So sorry that got so messy there. All right, that is it for lesson 10. Not lesson 10, chapter 10, lesson 6.